What is going on, guys? We are back playing some more Surviving with Mechanism version 10, and today we are going to be setting up polonium pellet production, which I know it sounds a little funny, it's kind of a tongue twister, but that is in fact what we are doing, and I think it's actually some pretty cool stuff to work with. It's also a bit dangerous, so it should be a fun episode. Now, the reason that we're doing this is because a couple episodes ago we set up the fission reactor, and we've been working with this now since we set it up, trying to make a closed loop system that can consistently run without having to worry us that something horrific is going to happen in the middle of our base. So initially we made the industrial turbine over here to deal with the steam and then condense it and send the coolant back so that the system doesn't overheat. And then we made the induction matrix over here to deal with the excessive power that we are getting from this so that the system does not back up and shut off, and then we have no coolant and the reactor melts down. And most people would think that if you can prevent the fission reactor from melting down, you're all set. Your base isn't going to blow up. You're not going to have any issues. Unfortunately, though, that is not the only thing that needs to concern you with the fission reactor. And I think one of the biggest concerns with it is the production of the waste that comes along with it. The byproduct of the fission reactor running is the production of nuclear waste. And there aren't really a ton of great ways to deal with that, but today we're going to be going over one of the easier ones that you need to do. The reason it's so interesting, I think, is because nuclear waste, while it is very dangerous and is a byproduct that in the end you really can't do anything with once it's been processed, you do need to process it to get a couple different crafting materials for a lot of the late game builds that Mekanism offers. So it kind of forces you to work with it, but you also got to be really careful when you're working with it so that you don't completely ruin the area you're working in by making it radioactive. So we're going to be going over all that today and making one of the three different possible crafting materials from nuclear waste. As I mentioned, we're going to be making the polonium from it. And if we look at the recipes, you can make polonium, you can make plutonium, and those are going to make plutonium pellets and polonium pellets. But you can also use the supercritical phase shifter with polonium to make antimatter, and that's going to make an antimatter pellet. So there's three different pellets that are going to be able to come from the nuclear waste. And unfortunately, the best one, which is going to be the antimatter, is going to be the hardest one to get to, but we'll make it there eventually. The reason that we are going to be setting this up today is because, number one, it is going to allow us to craft the Mekanism storage system stuff. So we're going to need the polonium pellets for that. And along with that, we need the polonium pellets and plutonium pellets to make the blocks required to assemble the supercritical phase shifter. So eventually, we'd like to pretty much process all of our nuclear waste using the antimatter process and the supercritical phase shifter, because that is going to produce no spent nuclear waste. But today we're going to be going over a process that is going to give us spent nuclear waste, but it will reduce it by a factor of 10. So I know that was a lot of information to throw at you guys. I promise we will be going over it all throughout this video, but we do need to get into the crafting because that'll be a really quick part that we can go over right now, since we really only have one new machine to work with, and the whole process only actually takes 2 machines. So the new one to work with is the solar neutron activator. This is going to require vision of the sky, so it doesn't necessarily need to have open blocks all the way up to the sky, but you could have glass over it, anything like that, but it does need to have a line of sight to the sky, and so you don't need any power for it. It's solar powered, and all you're going to do is pump in your nuclear waste, and you're going to get out polonium. And that's it. It's really simple. It's not super expensive. It does require some reinforced ally and elite control circuits, but then it also requires bronze. I think this actually might be one of the first times we've actually had to use bronze so far in Mekanism. It also requires an HDPE sheet, which is a little bit of a pain to make, but we're able to make the HDPE pellets really easily, considering we have the substrate and the ethylene from our farm right over there. So if you don't have that, it might be a little bit of a pain in the butt to make, but hopefully you have set that up, because ethylene is a very great power generation source that you probably should have utilized early on. Along with that, we're going to be making a pressurized reaction chamber. This is where we input the polonium and some water, and we will get out our polonium pellets and our spent nuclear waste. And then we're going to have a pump and some additional radioactive waste barrels, because the spent nuclear waste is still radioactive. So it needs to go somewhere, and that is going to be into the radioactive waste barrels. Like I said, it'll be reduced by a factor of 10, but we're still going to get some out because the only process that does not produce spent nuclear waste is the supercritical phase shifter that makes antimatter, and that's why that one is so good. But yeah, so we're going to jump in and craft all that. I'm just going to pull everything out right now, and we can quickly zoom through that so we can get into the super important parts of warning you guys how not to completely ruin your base. Also, things that we're not going to be crafting but are used in the process will be fluorite dust. That's going to go into the pressurized reaction chamber to make the pellets. I also have the ultimate pressurized tubes. Now, these are a little bit excessive. We're really not transporting that much nuclear waste, but these have a very high capacity, so they themselves, each one can hold a lot of nuclear waste. So it's a good idea to use these, or at least a higher tier of pressurized tube, in case your system gets backed up and you're not able to deal with it immediately or don't realize and can't shut off your reactor. Then these will prevent it from starting to vent off into the atmosphere around you. So we're going to use those, and then I have a quantum entangloporter just to use to bring power over to the setup and make it look a little bit cleaner. But if you do not have one of those or don't want to spend the resources on it, you can just wire over power like regular using a cable, and you'll be all good to go. So first things first, we're going to craft the solar neutron activator. Then we're going to make the pressurized reaction chamber, and we'll grab out our pump like so, and we'll make 2 radioactive waste barrels. Now, in the end, the radioactive waste barrels are only able to get rid of the radioactive material they hold at 1 millibucket every minute, so almost a negligible amount. A lot of people will store, across 1,000 of these, and then you're able to get rid of actually a decent amount at a time. But unless you want to bury a ton of these underground, I'm just using them for storage right now. The depletion of the radioactive material is essentially negligible because it's so slow. Now we're going to come over here and go downstairs. I made a nice little area for us to work in, but the first thing that I want to stress is when you are doing this, please be extremely careful. Most people will not work with this around their base because of how dangerous it is to actually mess around with, and the fact that you can very easily release radioactive material, which is going to cause you to have a bunch of issues, and essentially it's going to make the area you're in inhospitable. So there's no way to get rid of it unless you're in a creative world. There is a command to remove all radiation in case you are in a world that gets screwed up and you have the ability to go into creative, but chances are you guys are in survival. You're not going to have the ability to get rid of it, and that means that if you mess this up and it's by your base, you're going to be moving. So really, I cannot stress this enough that you have to be careful. And the way we're going to set this up today is right here. I have an opening up here to access the bottom of the radioactive waste barrel, which will act sort of as a buffer for us. But we are not going to hook it up and pull out the radioactive waste until we have everything else set up. And the reason being, if you break anything that has radioactive material in it, and do not be fooled, the polonium we're going to be working with, the spent nuclear waste, the regular nuclear waste, everything that we work with today other than the finished polonium pellet is radioactive. And any pipe or any machine or any container that has anything radioactive in it that gets broken is going to give it off into the atmosphere around you and completely irradiate the area that you're in. So essentially, once something has the material in it, you cannot break it until you get it out. And chances are that means putting it in something else that's also difficult to move. So you really want to make sure that when you put stuff down, you want it to be where it is and you are not going to move it for a very, very long time. So that's just the main reason that we want to be careful. A couple other ways that you can get radioactive material put off into the atmosphere is going to be if you are not processing the nuclear waste and the waste tank fills up on your reactor, it is not going to stop working. It's going to start venting it off into the atmosphere. So that's another reason you need to be very careful that you set this up and process this nuclear waste and deal with it, is because eventually it's going to be a problem and you're not even going to be alerted to the fact that it is. You don't need to mess anything up yourself or break the wrong block. You could just not touch anything. It's going to build up in your system, and before you know it, your entire base is going to be ruined. So we're going to be setting it up down here. You can see that I have a nice little area right here where we are going to be putting the solar neutron activator. Like I said, it does not need to, have direct vision to the sun. So even if the sun's over there, this will still count. It just needs the block directly above it to be able to see up to the sky. And glass is not a problem. So you can put glass down if you want to make sure that nothing's going to fall in if you're working in a basement or something like that. So mainly we're going to be working around the solar neutron activator. And this is going to go right here. Now, the reason we are going to put it up one is because we are inputting from the bottom. So the nuclear waste is going to come in the bottom of this, and then the polonium is going to come out the front. So we're going to grab the ultimate pressurized tubes and just come right along here. And like I said, we are not going to go all the way up, but we're going to go just like this. And we're going to wait to connect it up there. Even if we connected it, we need to set it to pull out. It won't automatically output, so we would still be fine. But we're going to bring it down here, input it in the bottom, and then the polonium that gets processed in here just through the solar power is going to come out the front. Now that needs to go right into the pressurized reaction chamber, which we are going to be putting right over here. So we'll come over like that, and we have the option of going down or to the top. So I think we'll just come over to the top like this, and we want to make sure that it's set to have, where's the gases? So the input is on the top, so that's all good. Now with this, if we come over and look at the uses for nuclear waste and look at polonium, we're going to put in polonium, and we're going to put in water, and then we're going to put in fluorite dust, and that's what's going to get us a polonium pellet in the spent nuclear waste. We also do need to provide this with power. But I should note real quick that if you guys are curious where the processing step is that reduces it by a factor of 10, it's actually the solar neutron activator, which is 10 millibuckets of nuclear waste to 1 millibucket of polonium. So this is really important just because the factor of 10 reduction is absolutely enormous. But I just wanted to make a quick note of that because I think I skipped over it. But now what we need to do is bring some power over here and make sure that we have water coming in and regular power. So I think what we're going to do is come down below this and put down our quantum entangloporter. And I also am realizing now that we do not have any water right here. So we're going to want to go grab some. Do any of these need water over here that we're filling up? I think we should have water going in down here. So we're just going to hop down here and quickly get some because we're going to need that. But yeah, we're going to put down the quantum entangloporter below this, and we are going to hook that up to power. And we're going to make sure, because I don't remember, I think we have something else in the power one. We're going to make sure that these are all, we shouldn't have any issue with this, I think. Let's set it to power and see what's in there. So it's got hydrogen. We don't really need to worry about that going in there, so that's fine. So we're going to make sure that the energy is outputting everywhere. So is it set to, let's go to energy. There we go. So now it's powered. We need to put on auto eject. So we've got power to this, and we're also going to be using this to power the electric pump. And I think that we are going to put the electric pump, honestly, right here. There's no reason to not just put the water right here, throw the electric pump down right here, and we should be able to rotate it with this. Does it want to rotate the electric pump with this? Do we have to come, can we get it over here? There we go. Okay. So we now have this with power, and we're just going to put down a basic mechanical pipe right on top. That'll throw it right in the back. So that's all good. And now we're going to manually input the fluorite dust. It doesn't really make any sense in my opinion to, you could eventually automate this if you want, if you're trying to really quickly process the nuclear waste, but because this is not the lossless process, where you are not going to have any spent nuclear waste, it's not like this is going to allow you to consistently run your reactor because you are still going to have to deal with a radioactive material coming out. So we're pretty much only going to be using this to slightly reduce the radioactive material we have, but mainly to make the polonium pellets. So if you're curious, the fluorite dust is made by putting fluorite into a crusher and you get out fluorite dust, but I'm just going to manually do that whenever we need more. So now we are going to put the fluorite dust in here, and the output's going to be the polonium pellets, which we can grab out manually. And then this one right here is going to be the spent nuclear waste. So if we look at the side configurations for the gases, the output right now is on the right. So we're going to want the output to actually be on the left. So that's going to be right over here. And we're going to put the pressurized tubes. For now, I'm just going to use 2 radioactive waste barrels that we're going to put right over here, 2 additional ones. Eventually, we can make a ton of these and bury them somewhere. Again, my goal is to try to not do that, but if we need to, we can. So we can just input this in the top really easily, just like that. And if we eventually needed to pull stuff out of these, you can pull it out the top or the bottom, but you need to remember that you have to set it to pull since these don't automatically output. So I think everything actually should be set up now. It is nighttime though, so we're going to go sleep real quick so that when we turn it on, we're actually able to see it function. That is one of the really important things to remember. If you are relying on this to process the nuclear waste and you do not have sufficient buffers at the beginning of the setup, you have it at the end, you need to make sure that it makes it through the solar neutron activator. And if it's not daytime out, this thing's not going to be working and your system's going to get backed up. So you want to make sure you have a buffer on both ends unless it's always daytime. So chances are it's not going to be. Make a buffer on both sides. And also, pretty much since a lot of things in Mekanism require solar power, try to sleep as much as you can. Also, a side note for those of you still watching, you cannot, a lot of people like to do this in the end because it's considered always daytime, but something that's really important to remember is that you cannot use nuclear waste with a quantum entangloporter. So it does not work with that. So you would have to have everything there if you're trying to do that. Because I know that a lot of people like to use the solar neutron activator there since it's always daytime. But again, I'm super nervous doing this. But I think we're good to hook this up, and then I'm not touching the disassembler because I do not want to break anything, because breaking any part of this, the minute we hook this up, breaking anything in this chain will completely ruin our base. So, okay, we hook this up, configurator, and we're going to want to make it set. So let's push and then pull. Okay. Here we go. So you can see it in there. It's lightly colored. And we've got nuclear waste right here. We got 8 millibuckets of it. It went in and we have 2 polonium pellets. So we've got a little bit of polonium, which you can see has a radioactivity level of 0.05. If we look in here, the nuclear waste has a radioactivity level of 0.01. And if we look up here, we actually have pulled out all the nuclear waste. So if we wanted to, real quick, we could flick on our reactor right here. Super loud. But if we came down here, we should see that this is able to continue functioning and we are able to produce more polonium pellets. But you're actually going to need a lot of this to make as many polonium pellets as you need. I think it is... We'll turn this off for now. Whew, that guy is deadly around nuclear waste. Do not let stuff blow up around this stuff. But I think it's something like 50,000 millibuckets of nuclear waste to make 1 polonium pellet. But if we look over here, you can see now that we have 999 millibuckets of spent nuclear waste in each of these barrels, which is roughly 2%. And if we waited a minute, it would go down by 1. So we've already, through what we've processed, we've greatly reduced the amount of nuclear waste that we have in terms of, by a factor of 10, as I said, which is great because these fill up pretty quickly, but still it's an absolutely crazy amount of time for these to get rid of it if you're just waiting for it to passively degrade. So I think it's going to be it for today, guys, though. Hopefully you enjoyed the episode. I cannot stress it enough. Please be super careful. If you have any questions, please ask them in the comments before you do any of this, because you want to make sure that you're doing it right. Because if you're doing it near your base, you do not want to ruin your base. It's a really horrible way to have to ruin it. So please be careful with it. Because in Mekanism, it's made to be realistic with this sense. I know a lot of the stuff in here is not realistic, but this one is very realistic in that there's no way to get rid of the radiation. It's going to be around for a long, long time. So yeah, be very careful. Hopefully you guys had an awesome Thanksgiving. That was a couple days ago when this video is going up, and that's why there was a slight delay in the next video coming up because I was busy for the holidays. But hopefully if you guys did celebrate it, you had an awesome Thanksgiving. If you didn't celebrate it, I hope you had an awesome random Thursday. That means absolutely nothing to you, since I know a lot of my viewers are not in the US and don't celebrate it. But that's going to be it for today, guys. Hopefully you enjoyed the video, and I will talk to you later.
Standing in a glass bowl at the end of a black hole, cold, lost and upside down.